You know the feeling, right? You spend a whole weekend grinding, studying for that big math test, and you get a grade that just does not match the effort you put in. Well, you are in exactly the right place. We're going to break down why that keeps happening and, more importantly, what the actual science of learning says you can do about it. I mean, it is one of the most frustrating feelings ever, isn't it? You put in the hours, you read the textbook, you pored over your notes, you watched all the lecture videos, you genuinely felt like you knew the material. So, what went wrong between your study session and that exam paper? Well, it turns out the answer has way less to do with how much you study and everything to do with how you're studying. Okay, let's dive into the first big idea here, something I call the recognition trap. You see, our brains are kind of sneaky. They're amazing at making us feel like we're being super productive when really we're just spinning our wheels. This happens when we mistake being familiar with something for actually mastering it. Let's look at this side by side, because this is so important. On the left, you've got passive review. Think of this like a one-way street. Information is just flowing into your brain. Rereading your notes, highlighting pages, rewatching a lecture. It all feels productive, but it's basically like watching someone else lift weights. You're not building any muscle. Now, on the right, that's active recall. This is a two-way street. You are actively pulling information out of your brain. Quizzing yourself, solving a problem from scratch, trying to teach the idea to someone else, that is the real workout for your brain. So here's the bottom line. When you just reread your notes on, say, derivatives, your brain goes, oh yeah, I've seen this before. I know this. That's just recognition. But think about it. On an exam, the professor doesn't ask you to recognize the formula from a list. You have to recall it from thin air and then apply it. By only practicing recognition, you're building this false confidence that just completely evaporates under the pressure of a real test. Okay, so that leads us right into our second big myth. Most of us have this gut feeling that learning should feel easy. You know, if it's a struggle, we must be doing it wrong. But what the research shows is kind of shocking. The exact opposite is true. Real, long-lasting learning is actually supposed to feel hard. This quote from the incredible cognitive scientists, the Bjorks, just hits the nail on the head. Let that sink in for a second. The study methods that make you feel like you're learning super fast, those are often the absolute worst for remembering it in the long run. Easy learning is fleeting learning. It's here today, gone tomorrow. And this brings us to this amazing concept called desirable difficulties. Now, these aren't just any old roadblocks. They're specific, productive struggles that you introduce into your learning process. They force your brain to work harder to understand and retrieve information. It's exactly like adding more weight to the barbell at the gym. It's tougher, for sure, but that's what actually builds the muscle, or in this case, a stronger memory. Check out this classic study that shows this perfectly. So in this experiment, one group of kids practiced throwing a beanbag at a target 3 feet away, over and over and over. Another group practiced throwing at targets that were 2 feet away and 4 feet away, but they never practiced at the 3-foot test distance. So when they were all tested from 3 feet, who do you think did better? It was the group that practiced at the random distances. That varied, more difficult practice built a more flexible, more robust skill, even though it probably felt way harder and less successful while they were doing it. And this chart just shows the huge gap between our perception and reality. When you ask students, they almost always say that the easy, repetitive practice, what researchers call blocked practice, feels way more effective. That's that high bar for what they judged their performance to be. But when you actually measure their long-term learning, the difficult, mixed-up practice, called interleaved practice, wins by a mile. It just goes to show our intuition about what works is often completely wrong. All right. Let's talk about the all-nighter, that desperate, last-minute cram session before a huge calculus final. Researchers call this massed practice, and it is probably one of the most popular and yet most flawed study strategies out there. It's built on a total misunderstanding of how our memory actually works. Look, cramming might help you pass that test tomorrow. I'll give it that. It gives you a little boost in short-term performance. But that knowledge is built on a foundation of sand. A week later, it's gone. The real powerhouse is something called the spacing effect. This means studying a topic for an hour today, then touching on it again in a few days, and then again next week. I'm not exaggerating when I say this is one of the most proven, most powerful laws of learning ever discovered. It lets your brain forget a little bit, which makes the next time you try to remember it more effortful, a desirable difficulty, and that's what makes the memories stick for good. Okay, so we've busted the myths. We've torn down the old, broken ways of studying. Now, let's build something better. How do we take all these powerful ideas, active recall, desirable difficulties, spacing,
and turn them into a real, concrete study plan you can start using for your math class tonight. Okay, first up, one of my absolute favorite active recall methods, the Feynman technique. It's simple. Pick a concept you're learning, like the Pythagorean theorem. Now, pretend you have to teach it to a little kid. Explain it out loud in the simplest terms you can think of. The second you get stuck, or you have to say where you use a piece of jargon you can't explain, bingo, you've just found a gap in your own understanding. That's pure gold. Now you go back to your notes, figure out that one piece, and then try your explanation again until it's perfectly smooth and simple. This forces true understanding, not just recognition.
Next, let's totally revamp your flashcards. Most of us just use them to passively look at answers. To turn them into a powerful active tool, you gotta follow these rules. First, one single concept per card. Second, and this is the most important part, you have to force yourself to write down or say the answer before you flip the card over. That's the active recall. Third, don't just write down the quadratic formula. Write a simple sentence explaining why it works. And finally, here's the key. Mix in cards from earlier chapters. This is that interleaving we talked about. It's going to feel harder, but it builds that flexible knowledge that you can actually use on a test. So if there's one thing you take away from all of this, let it be this. It's time to make a shift. Stop being a passive sponge for information. Stop just rereading, highlighting, and hoping it sticks. You have to start actively retrieving. Start testing yourself, explaining concepts, and making your brain really work for it. That productive struggle isn't a sign you're failing, it's the feeling of you actually learning. So, I'll leave you with a challenge. A question to really think about. Based on everything we just talked about, what is one passive habit you have that you are going to replace with an active one this week? Are you going to stop rereading that chapter and try the Feynman technique instead? Are you going to turn your boring old flashcards into a real active recall machine? The path to finally getting the grade you deserve in your math class starts with that one small